Good morning, everyone. My name is Shekhar Reddy, Senior Physics Faculty. So, welcome to GPSR Physics classes. So, today we are going to discuss about connected bodies by a string. So, this is Newton laws of motion applications. So, here connected bodies mean two bodies or more than two bodies under different conditions. So, these are applications for Newton second law of motion. So, here connected bodies. So, first, motion of a connected bodies. First case, oddwood mission. So, oddwood mission is known as one of the small mission, two bodies of masses connected by a string, and the two masses passes over a frictionless pulley, frictionless and massless pulley. So, using this is to find the acceleration due to gravity at a given place. So, now oddwood mission. So here two bodies of masses, each mass m1 and m2, m1 greater than m2, connected by a string and passes over a frictionless and massless pulley. Find acceleration and tension in the string. So now consider pulley. Like this is pulley. Fixed as support. So this pulley as frictionless and massless. Now string consider inextensible and a massless string connected by two masses m1, one end of the string, the other mass m2. So these are two masses m1 and m2. Here condition is m1 greater than m2. m1 greater than m2 at the same time this pulley is frictionless. So if the system is released, the masses passes over the pulley. Here m1 greater than m2 means so m1 moves downward direction, m2 moves upward direction. So m1 moves upward direction means the acceleration of the body upward direction. M2 downward direction. Here acceleration of the body downward direction. Now weight acts on the M1 gravitational force. That is always downward direction. M1G. Tension developed in the string. Tension nothing but tensional force. T. Upward direction. So same thing, the weight of the mass M2 also downward direction. Tension T2. Sorry. If the massless string means tension in the segment is same. T. Yeah, T. Both are upward direction. So now make the equation for mass 1, equation for mass 2. So that equation written purpose will draw the free body diagrams. So initially draw the free body diagram for M1. FBD, free body diagram for mass M1. So here what is free body diagram? Like this is known as two mass system. In two mass system, our aim is free body diagram for M1. So this M1 isolate from the system and draw the diagram and showing all type of forces acting on them. Showing all type of forces acting on them. That is known as free body diagram. So initially M1 free body diagram for M1 means M1 isolate. So M1 isolate. So how many types of forces? Either vertical or horizontal forces and showing diagram that is known as free body diagram. So now M1 isolate from the system that M1 mass taken as point mass, weight downward direction, tension upward direction. Here, what is the acceleration? Acceleration downward direction. That means the resultant force. So here we know that like this is horizontal x direction, vertical y direction. Here summation fx0 summation fy is equal to ma. So diagram. So like this is free body diagram, gravitational force or gravitational force something but weight downward direction, tension upward direction, the motion downward direction. What is the result? Acceleration downward. Now write the equation from Newton's second law of motion. From Newton's second law. Summation F5, F is equal to MA. F is equal to MA. So your body moves down me, your M1 greater than tension. So that means M1 G minus tension force is equal to resultant force. That means. So your net force F is equal to, we have to write like this. Your F net is equal to F net is equal to M1G minus tension. So that is equal to mass 1 M1A. Let be equation 1. Okay, here M1 G downward direction, tension upward direction. So since here M1G greater than tension, that means M1G minus tension is equal to M1 into A. From Newton's second law of motion, like this is formula. Here F is equal to net force, nothing but resultant force. That net force is equal to how much? M1G downward direction, T upward direction. M1G more than 2 tensional force. That means M1G minus tensional force is equal. So M into A. M into A. So next to now separate M2 and draw the free body diagram. ABD for M2. At the same time, M2 also isolate from the system. Weight always downward direction. Tensional force upward direction. Your body moves up, acceleration upward direction. So that means like this is point mass, weight to downward direction, tension away from the mass, nothing but point. That mass considered point mass, always tensional force away from the point or mass. So here the acceleration upward direction. That means according to Newton's second law of motion, from F is equal to MA. So here F is equal to net force. Your body moves up means tensional force greater than 2 weight of the body. So that means here F is equal to T minus M2G, that is equal to M2 into A. Let it be equation 2. This is equation 1. This is equation 2. Now here what is the asking? Acceleration and tension. First we will find the acceleration of the system. First we do. Acceleration of the system. For acceleration, equation 1 plus equation 2 on both sides. Equation 1 plus equation 2 on both sides. Equation 1, this is equation 2, that one. So left side, first equation, m1g minus t. Second equation, left side, t minus, that means plus t minus m2g. First equation, right side m1j. Second equation, right side m2a. A will take common m1 plus m2 into a. m1 into m2 into a. Here minus t plus t get cancelled. So remaining m1g minus m2g. So same thing here. G is also common. m1 minus m2 into g is equal m1 plus m2 into a. So now acceleration is equal, or therefore acceleration is equal m1 minus m2 by m1 plus m2 into g. So this is acceleration of the system. Okay, using this formula to find the acceleration of the two bodies suspended two ends of the string, that is passes over the pulley. Suppose here if m1 is equal m2, that is acceleration a is equal 0. Acceleration a0 means the system is in equilibrium. The system is in equilibrium. The system is in equilibrium. Acceleration 0. So next to second bit, tension in the string. In the string. Tension in the string. So tension in the string, our requirement tension. Tension purpose. So equation 1 m1 g minus t is equal to m1 a. For tension, a value substitute in equation 1. In equation 1, where is equation 1? m1g minus t is equal m1 into a. m1g minus t is equal to m1 a value. A value how much? This one. m1 minus m2 by m1 plus M2 into G. M2 into G. So tension transfer that side, this is transfer here. M1G minus M1 M1 minus M2 by M1 plus M2 into G is equal tension. G is equal tension. So in this equation, M1G will take common. M1G common. We have one remaining minus M1 minus M2 by M1 plus M2. That is equal tension. That is equal tension. So now we'll take LCM. LCM M1 plus M2. So this is your denominator 1. So this is dividing by 1 and multiplying. M1 plus M2. Now bracket record. So inside the bracket plus M1 minus M2. So that means minus M1 plus M2. Tension. So here plus M1 minus M1 gets cancelled. M1G M2 plus M2. 2M2 by M1 plus M2 is equal to T. Okay, so it is simply we have to write T is equal. So M1G to M1 M2. That means 2 M1 M2 by M1 plus M2 into G. This is tension in the string of the two body system or outward mission. Outward mission. So like this is the acceleration. So this is tension in the string. So next one sometimes asking reaction force on the pulley. Reaction force on the pulley. Reaction force on the pulley. So let me R. Tension. Now R is equal to T plus T. R upward direction, tension, double direction. 2T. So now R is equal to tension value substituting. R is equal to 2 into 2M1 M2 by M1 plus M2 into G. So therefore reaction force R is equal to 4 M1 M2 by M1 plus M2 into So that like this is reaction force on the pulley. Reaction force on the pulley. Suppose another note, this tension in terms of weight. So numerator and denominator multiplying with extra G. Now tension. Tension in terms of weight. So this equation, tension in terms of mass, this equation multiplying and dividing with the extra G. So like this G multiplying M1G, next extra G, M2G. Here numerator, denominator, G multiplying M1G, M2G. So that means tension is equal to M1G, M2G by M1G plus M2G. So therefore T is equal to W1, W2 by W1 plus W2. So this is tension in terms of weight. This is tension in terms of the weight. So very most important question for solving numericals, either MSET or NEET or JEE. So thanks for watching this video. So please like, share and support to me and subscribe.